additional cash flows of 50,000 per year for the next 4 years. The discount rate for these cash flows is 10% per year. Number 1. What is the present value of the expected cash flows from the machine over the next 4 years when it's been discounted semi-annually? Okay. So colleagues, when you're doing these questions, this is what you need to look for. Is the discount period equal to the payment period? Okay, that's the first thing you look for. Is the discount period equal to this payment period? The payment period is after each year. After each year, you're getting 50,000. Okay, so the payment period is annual. It's once. Now here, the discount period in this question says it's discounted semi-annually, meaning the rate is discounted twice per year. So what you need to do first is you need to equate the discount period and the payment period. Okay, colleagues, discount here, making the discount period equal the payment period. So since our discount period is semi-annual, we want to make it annual. And this is where the effective annual interest rate comes in. Okay? The effective annual interest rate just converts these rates that are compounded semi-annually, quarterly, just gives you your overall annual return. Okay? So this is the formula for the effective annual return. So hold on, please. Sorry, I got a call there. Yes, so we need to equate the discount period and the payment period. So the effective annual interest rate, this is the formula here. Okay, 1 plus the rate over, it has to be the number of compoundings, put it like this, EAR equals 1 plus the rate, okay, over M is the number of compoundings, okay? M is the number of compoundings, okay? So since it's discounted semi-annually, so M equals 2, okay? Semi-annually means it's compounded twice. Or it's, here in this case, it's discounted twice. Okay, so M equals 2. Okay, so our formula goes from this to this. Okay. Our discount rate is 10%, converted into a decimal. The number of compoundings, 2 here. Okay. 0.1 divided by 2, you get 0.05. 1 plus 0.05, you get 1.05. Okay, remember this is squared. 1.05 squared. Colleagues, let's have our calculator so that we make sure these, so that when you get this document, you are not getting different values. So confirm with your calculators if 1.05 squared gives us this. Just confirm with your calculators. Okay, I believe you compare. So you get 1.1025. You subtract this by 1, you get 0.1025. Alright. And you multiply this by 100, this gives you 10.25%. calculated the discount period and the payment period. Okay, this discount rate is the annual rate. Okay. Any questions before I move further? Okay, so remember colleagues, this is an annuity here. Okay, we're trying to find the present value of the annuity here. Okay, because they're saying what is the present value of the expected cash flows from the machine over the next 4 years. So this is an annuity. Okay, annuity where you're getting the same amount of money over the same period of time. Okay, so we can now get the present value of our annuity. Okay, and this is the formula. Right. In your notes, it's like this: CF multiplied by 1 minus 1 over 1 plus R to the power N over R. Okay, colleagues? What has us changed is this here. These formulae are the same, okay? What has us changed is these two things here. Okay? But you still get the same answer if you use any formula. Okay? Yes. So the cash flows 50,000. Okay. Our rate 0.1025, 10.25. Number of years 4 years, as you can see, to the power negative n. N is 4 years. Okay. So when you do our tabulations, 1 plus 0.1025, you get 1.1025. To the power negative 4, you get 0.6830. Alright. Then you subtract 1 minus 0.683, you get 0.3168987. Then you divide now by 0.1025. You're going to get 3.0904. You multiply it by 50,000, you're going to get 154,520.19. Any questions? So always make sure discount period and payment period are equal. Don't just start solving, you'll get your answer wrong. How would the present value of Aria's investment change if the discount rate increased to 12% annually had been discounted quarterly? Okay. So here, two things have happened. Okay, the discount rate has increased from 10% to 12%.
Good evening, sir. Are you recording?
Yes.
Okay, all right.
Yes. This one was discounted semi-annually twice. Now he is discounted quarterly 4 times. Okay. So even with this one, part 2, we need to make the discount period equal the payment period. Because the payment period is after a year. So this discount period, we have to make it annually. Change it from quarterly to annually. So again, we use the effective annual interest rate. Okay. Here's the formula again. Okay, the rate is 12%. Since it's discounted quarterly, so M equals 4. Okay, since it's discounted quarterly, so m equals 4. So it's 1 plus 0.12 over 4 to the power 4 minus 1. 0.12 divided by 4, 0.03. 1 plus 0.03, you get 1.03 to the power 4. Okay. 1.03 to the power 4, you get 1.1255. Minus 1, 0.1255, or 12.55%. Okay. So we've annualized those the quarterly discounting. Okay, that has been annualized, the quarterly discounting. Okay. So what we've seen, when it was discounted annually, we got 10.25. Now when it's discounted quarterly, it's become 12.55. Okay. So when you increase the number of compoundings, even your effective annual interest rate is going to increase. So here's the formula for the present value again. Okay. Cash flow, 50,000, which are paid per year. Our rate is the effective annual interest rate. Okay, this is 0.1255. Number of years, they said this is for 4 years. Over 0.1255. So you just add 1 plus 0.1255, 1.255. Raise to the power negative 4, you get 0.563462. Anyway, so 1 minus 0.5634, you get 0.436538. Okay, divided by 0.1255, you get 3.4807. Multiplied by 50,000, you get 174,085. Okay. That is the present value. And we've seen the present value has also increased. Okay. The number of discountings increased. Okay, and even the present value. Because if we compare, colleagues, we saw when the number of discountings was semi-annual, where it's discounted twice a year, the present value was 154,000. Now, if we increase the number of discountings to 4 times a year, okay, we saw the rate increased first, and then after the rate has increased, even our present value has increased. Okay. So if you increase the number of discountings, is the number of discountings, then your present value is going to also grow, as we have seen. Any questions, colleagues?